You know, usually when we talk about a traditional university degree, there is this underlying expectation of, well, a guaranteed, almost mechanical path.
Right, like a conveyor belt.
Exactly. You step onto this escalator during your freshman year and you ride it smoothly and passively for 4 years. And eventually, the university points to the exit and just hands you a career.
Yeah, it is a very linear, comforting idea.
Yeah.
I mean, you put the time in, you get the paper out.
And society just universally recognizes that paper as a proxy for your competence, you know?
We really like life to be predictable like that, safely categorized into these neat little 4-year blocks where someone else is essentially doing the driving.
But then you step into the world of artificial intelligence today, and suddenly that escalator is completely shattered.
Oh, absolutely destroyed.
We are looking at an educational landscape that is genuinely terrifying for a lot of people right now. I mean, you are sitting there and you watch a chatbot, whether it's ChatGPT or Claude or Gemini, and it writes a passable, heavily researched master's thesis in roughly 45 seconds.
It's staggering to see it happen in real time.
Right. And then you look at your massive tuition bill or maybe your kid's tuition bill, and you have to ask yourself a very uncomfortable question.
Why pay for it?
Exactly. Why on earth would anyone spend 4 years sitting in a dusty lecture hall just to memorize things a machine can instantly recall and synthesize?
It is the absolute definition of an existential crisis for higher education. I
Yeah.
mean, the anxiety you were describing is palpable everywhere, from the student dorms all the way up to the dean's office.
Oh, I bet.
People are legitimately wondering if the traditional university is just a few years away from going the way of the horse and buggy, you know?
And that exact existential panic, that very modern anxiety that traditional universities might become completely obsolete, is what we were tackling head on in our deep dive today.
It's such a crucial topic.
It really is. So we are exploring a visionary framework by T.S. Vitun An. He is the founder of A-Work AI University and co-author of the AI Competency Framework. We're pulling from his incredibly detailed piece titled, Universities Won't Disappear, but Become the Guiding Pillar of a New Educational Ecosystem in the AI Era. And let me tell you, this isn't just an academic thought experiment.
No, it really reads like a literal survival blueprint for higher education.
It does. And the core thesis he presents completely flips the current doom-laden narrative on its head.
Yeah, he argues that we are undergoing a massive paradigm shift. Knowledge simply no longer lives exclusively in the lecture hall, right? And learning is no longer tethered to a physical classroom.
Right, the geography of learning has totally changed.
Exactly. But the crucial takeaway here is that the university isn't dying. Instead, it is being violently forced to evolve from a deliverer of information into an architect of a massive new ecosystem.
Okay, let's unpack this because we have a lot of ground to cover today, and we are going to trace this transformation step by step.
Yeah, there's a lot to get through.
First, we need to look at why simply handing out iPads or recording lectures isn't going to save these institutions.
A fresh coat of paint won't fix a broken house.
Exactly. Then we are going to explore this groundbreaking four-pillar co-creation model the author proposes. And this brings AI, corporate CEOs, and shared physical infrastructure into a single cohesive system.
Which is wild to think about.
It is. And ultimately, we're going to discover how this completely reshapes what it means to be a learner or a professional today.
I mean, the stakes couldn't be higher here. If institutions fail to understand this framework, they will fade into irrelevance. But if they do adapt, well, they might become more powerful and essential than they have ever been.
Right. But before we jump into the cure, we really have to look closely at the disease. We need a total revolution instead of just a software update for the existing system.
Yeah, a patch isn't going to cut it.
And the author makes a very nuanced point right out of the gate here. The natural instinct is to blame the technology, right? To say that AI is destroying education.
It's the easy scapegoat.
But he clarifies that the crisis isn't actually caused by AI at all. The crisis is the old university model itself. AI is just the floodlight exposing the massive cracks in the foundation.
Yeah, the traditional model is fundamentally closed off.
Yeah.
It operates like a medieval walled city, you know?
Yeah.
It's entirely separated from the real world of business and industry.
Completely isolated.
Right. And because of those walls, it is agonizingly slow to update its curricula. I mean, think about the mechanics of how a university operates today.
Oh, the bureaucracy is legendary.
It really is. By the time a faculty committee notices a new technological trend, forms a working group to discuss it, drafts a new syllabus, gets it approved by the academic board, and actually begins teaching it to a freshman.
That technology is already 4 years out of date by the time that student graduates.
Exactly. It's completely obsolete before they even get a diploma.
Anyone who has recently graduated, or honestly, anyone who has tried to hire a recent graduate, knows exactly what you mean. There is this massive friction point, this competency gap, that the source material highlights.
Businesses desperately need real capabilities from day one.
Right. They need someone who can jump into the deep end of a complex project and just start swimming. But students desperately need real experience, which they simply aren't getting from a theoretical textbook published a decade ago.
And nature abhors a vacuum. Because the traditional universities are failing to bridge this gap, alternatives are aggressively stepping in to fill the void.
Yeah, you look at platforms like Coursera, Udemy, or edX, they are stepping in to replace traditional training modules because they are just infinitely faster.
And much more relevant to what the market actually demands today.
Exactly. I mean, a company like Google or IBM can just put out their own specialized certificate that teaches exactly what they want their new hires to know.
Why wouldn't they?
Right. So if you are a student looking at the market, why would you wait 4 years for a university to catch up to what Google is offering right now for a fraction of the cost?
You wouldn't. I mean, it makes no economic sense.
Right.
And that brings us to the trap that many universities are falling into right now as they start to panic.
Oh, the digital band-aids.
Yes, they think the solution is just to take their old broken model and put it on the internet.
This is a really critical point. If a university just takes its outdated 2-hour recorded lectures and slaps them onto a private online portal, aren't they just clinging to the past?
Absolutely.
The medium isn't the only problem, it's the product itself. As the author says, if they don't fundamentally change their approach to knowledge, they are just digitizing obsolescence.
Digitizing obsolescence is a devastatingly accurate phrase.
It really is.
Merely adding technology, whether it's broadcasting lectures on Zoom, creating online multiple-choice quizzes, or even just letting students use AI to spell-check their essays, to a fundamentally broken, siloed model does not fix the model.
It just makes the failure slightly more efficient.
Exactly. The shift, according to the author's vision, must go from being a place of teaching, a physical location where an expert talks at you, to becoming an architect of the human resource ecosystem.
I really want you, the listener, to reflect on your own educational experiences for a moment. Think back to your degree. How much of what you learned was pure abstract theory that you just crammed into your head for a final exam and then immediately forgot?
Most of it, for a lot of people.
Yeah. Now contrast that with the skills that were immediately applicable the first week you sat down in a professional environment. For most of us, that ratio is heavily skewed toward theory.
And that specific skew is exactly what is causing the system to collapse under the pressure of AI. Because if all a university is offering is theory, historical context, and raw information delivery, well, AI can do that a million times better, faster, and cheaper.
Without breaking a sweat.
Right. The university has to find an entirely new reason to exist.
Which opens the door to the solution. If the old model of a professor lecturing at a chalkboard to 300 silent students is obsolete, who actually does the teaching in this new world?
This is where we get into the framework.
Yes, this introduces the first 2 pillars of Thun An's framework. Let's start with Pillar 1, which is the university as the guiding center. And the operative word here is guiding instead of teaching.
A very important distinction.
In this new strategic role, the university completely steps away from rote teaching. It no longer views itself as the primary deliverer of facts.
Which is a massive psychological shift for these institutions. I mean, if they aren't delivering the facts, what are they doing?
Right.
Well, they design the learning outcomes. They ensure the academic foundation is rigorous. They act as the grand coordinator of this vast new educational ecosystem. And crucially, they handle the accreditation and quality control.
So they are setting the rules of the game.
Exactly. They define the standards of competency rather than delivering the raw information itself. Think of them as the general contractor building a skyscraper.
Oh, I like that analogy.
The general contractor doesn't personally pour the concrete or weld the steel beams,
Yeah.
But without them, you just have a chaotic, dangerous pile of building materials.
So the university sets the blueprints. They say, to be considered a competent mechanical engineer in the year 2026, here are the exact standards, the problem-solving capabilities, and the practical experiences you must prove you have.
Yes.
But they don't necessarily have to be the ones standing at a podium reading you the manual on thermodynamics.
Because reading you the manual is a terrible use of a highly educated human being's time. especially when we have Pillar 2, which is where the technology actually integrates into the system, rather than just hovering on the periphery.
So Pillar 2 is AI as the knowledge infrastructure. This is where the framework gets incredibly futuristic, but honestly, it's built on technology that is available right now.
We have the tools today.
We do. In this model, AI, like these advanced large language models, becomes the foundational layer of education. AI essentially becomes the ultimate personalized 24/7 tutor for every single student.
The author outlines very specific duties for AI in this ecosystem. First and foremost, it handles the delivery of all basic foundational knowledge.
So the rote memorization stuff.
Right. And it enables completely personalized learning paces. Imagine a student learning complex statistics. If they understand a core concept in 5 minutes, the AI tutor moves them forward immediately.
No waiting for the rest of the class.
Exactly. But if they need 5 days and 20 different practical examples to understand the next concept, the AI patiently works with them without holding back a class of 300 other people.
That is huge.
Yeah.
And it also performs continuous assessment. It completely eliminates the terror of the midterm and the final exam.
Thank goodness for that.
Right. Instead of high-stakes testing, the AI is constantly evaluating your understanding through daily conversation, interactive problem solving, and running practical simulations with rapid feedback.
It's a much more natural way to learn.
You can debate historical economic policies with an AI persona acting as a 19th century industrialist, or have it review your software code line by line instantly at 3 a.m.
It democratizes the kind of intensive one-on-one tutoring that historically was only available to royalty or the ultra-wealthy. You have a dedicated expert solely focused on your individual learning curve.
I hear that, but I have to play devil's advocate here for a second.
Sure, go ahead.
If I am an 18-year-old taking on massive debt or, frankly, just spending 4 years of my life on this, why do I care about the university's stamp of approval? If the AI is the one doing the actual tutoring, the pacing, the continuous assessing, and the feedback, aren't universities just becoming glorified, incredibly expensive rubber stamps?
That's the big fear, isn't it?
Yeah. I just want the skills the AI teaches me so I can get a job. How does the university convince the student to pay them?
What's fascinating here is that this is the most common objection to the model, but it misses a vital component of how the real world operates.
Okay, lay it on me.
AI is undeniably brilliant at delivering information, summarizing data, and running closed-loop simulations. But AI entirely lacks human context, strategic long-term direction, and practical judgment.
Expand on that a bit. What do you mean by practical judgment in this context?
Well, think about it like this. An AI can teach you how to write a highly efficient, lightning-fast financial trading algorithm perfectly. It can debug the code and optimize the processing speed.
Right.
But it lacks the human context to understand how that specific algorithm interacts with unpredictable real-world market panic, or how it aligns with the strategic goals of a specific firm.
I see.
The university's role as the architect and quality assurance body becomes paramount here. They curate the ecosystem to ensure the AI is teaching what the real world actually needs within a framework of rigorous academic standards and practical judgment.
So it's the difference between having access to every book in the world and having a master librarian guide you through them so you actually build a coherent, applicable worldview.
That's a perfect way to put it.
The university is the guarantor of meaning and quality.
They validate that the human interacting with the AI has actually achieved a standard of excellence, resilience, and strategic thinking that society and employers can trust.
Because the AI can't vouch for your character.
Exactly. In a world completely drowning in infinite AI-generated information, the entity that can verify, curate, and guarantee quality becomes the most valuable player in the room.
Okay, that makes sense. We have the architect, which is the university setting the standards and ensuring the context. And we have the foundation, which is the AI patiently drilling the basic knowledge and running simulations with the students 24/7.
The first two pillars.
Right. But that still leaves a massive hole in the real-world application. Who teaches the cutting-edge, highly nuanced, intensely practical skills? Because AI can only teach based on historical data it has been trained on, and traditional academic professors often haven't worked in a fast-paced corporate environment for decades.
Which brings us to Pillar 3, perhaps the most revolutionary and logistically challenging part of this entire blueprint. This is the practical human ecosystem.
The author outlines several human elements that need to be brought into the fold to bridge this gap. He mentions utilizing retired lecturers, not necessarily to teach outdated tech, but to act as mentors and academic reviewers because they have incredible pedagogical experience.
Right. They know how people learn.
And he mentions alumni who are brought in specifically for job connections and career orientation. But the centerpiece of this pillar is what he calls the tech expert faculty system.
This directly addresses the most glaring flaw in higher education today. The absolute best industry experts, the visionary founders, the lead engineers developing cutting-edge technology, they are all outside the academic system.
Because they are out there actually doing it.
They're busy running companies and building the future. And traditional universities currently have absolutely zero effective mechanisms to bring them in to teach, other than, the occasional superficial guest lecture.
And Tunon doesn't just say universities should invite more guest speakers. That would be way too easy. He outlines a highly structured, 6-step mechanical solution to fundamentally integrate these working professionals into the core curriculum.
It's a very rigorous process.
Let's break down this framework step by step, because the friction of actually implementing this is where it gets fascinating. Step 1 is the creation of a national expert directory.
This involves digitizing and rigorously tiering expert profiles on a national scale. You are basically creating a verified, comprehensive database of industry professionals who have proven capabilities and a stated willingness to contribute to the educational ecosystem.
But you can't just throw a brilliant software architect into a room full of 20-year-olds and expect magic to happen. It's usually a complete disaster.
Oh, it usually is. They speak completely different languages.
The expert knows how to do the job, but they don't know how to deconstruct their knowledge for a beginner.
Which is exactly why Step 2 is so critical. Pedagogical standardization.
Yeah.
Just because you are a genius coder or a highly successful manager doesn't mean you have the slightest clue how to actually teach.
It's a completely different skill set.
It really is. So the framework mandates giving these industry experts short-term, highly focused pedagogical training and providing them with teaching certificates.
Like a boot camp for teaching.
Yeah, you have to equip the practitioner with the tools of an educator so they know how to transfer their knowledge effectively, how to assess understanding, and how to structure a learning module.
That sounds great in theory, but step 3 is flexible participation. And this is where the traditional university model really has to bend until it almost breaks. Historically, to teach at a university, you have to commit to a full semester, 16 weeks, every Tuesday and Thursday at 10 a.m.
And no active tech lead or founder can do that.
Exactly. Their schedules are entirely unpredictable.
The model changes the fundamental rules of engagement here. It allows these experts to teach micromodules.
Okay, what does that look like?
Instead of a 16-week commitment, maybe they come in for an intensive 3-day weekend workshop. Or they act as an asynchronous mentor for a specific 4-week capstone project. They contribute in highly impactful, concentrated bursts that actually fit the reality of their professional schedules.
And step 4 flips the geography of learning entirely. Enterprise as a training facility. The campus is no longer just the ivy-covered brick buildings or the traditional lecture halls.
Right, getting out of the classroom.
The author proposes officially recognizing the business itself as a campus annex. Students go into the actual corporate headquarters, sit in the actual offices, and do real, structured work as part of their accredited degree.
But to ensure that isn't just glorified, unpaid busy work, you need accountability. That is step 5. Clear KPIs or key performance indicators.
You can't just hope it works.
You don't just hope this collaboration works. You measure it relentlessly. You measure the success of this expert integration by tracking their teaching hours, the direct outcomes and capability improvements of the students they mentored, and, most importantly, the actual recruitment numbers.
Did they get hired?
Exactly. Did the students taught by this specific expert actually get hired in the industry?
But let's look at step 6, which is risk management. If I am running a highly competitive robotics firm, I'm not going to let a bunch of college sophomores wander into my R&D lab to look at my unreleased prototypes just for the sake of education.
No, the liability is too high.
The threat to trade secrets is massive.
It is a massive barrier, and it's why these collaborations often fail today. The framework solves this by building robust legal and operational guardrails. It involves utilizing strict non-disclosure agreements that have real teeth, implementing careful content moderation to clearly separate proprietary trade secrets from foundational educational principles.
And using co-teaching models. How does the co-teaching model mitigate that risk?
Well, the university professor is physically or virtually in the room with a corporate expert. The academic ensures that the rigorous educational goals are being met, while the corporate expert ensures the practical application is sound, and the company's legal team ensures that boundaries are clearly defined and protected.
It is a shared responsibility.
Exactly.
Here's where it gets really interesting. I look at this six-step system, and I think of it like building a culinary apprenticeship in a Michelin-star kitchen, but applying it to every single industry.
That's a great comparison.
You aren't stuck with one culinary historian who hasn't cooked a meal in 20 years. You are bringing the student into the kitchen, having them prep the ingredients under the guidance of the sous chef, while the university ensures they actually understand the chemistry of what they are cooking.
Or like drafting a fantasy football team for your education.
Exactly. It completely eliminates the slow curriculum update problem we talked about earlier. You don't need a faculty committee to update the syllabus if the person teaching the module is the one inventing the new technology in real time.
The curriculum becomes a living, breathing entity that updates automatically as the industry evolves. The gap between what is taught and what is needed drops to zero.
So we have constructed this incredible digital and human network. We have the university setting the vision and the standards. We have AI working as the tireless, personalized foundation. We have active professionals dropping in for specialized hands-on training.
It sounds complete.
But wait, we've only solved the digital and intellectual side of the equation. You can't learn fluid dynamics, advanced robotics, or biochemistry purely on a chatbot or in a corporate boardroom. How do we solve the physical hardware problem?
You need physical spaces that match the ambition of this digital and human network. And that brings us to Pillar 4, breaking down walls with shared educational infrastructure.
The source outlines a really tragic physical infrastructure problem that currently plagues the system. It is a tale of two massive inefficiencies. On one side, you have university labs. They are incredibly expensive to build, requiring millions of dollars in grants and endowments, but they are often heavily under-optimized. They sit completely empty during the summer months, or they slowly become outdated because the universities simply cannot afford to buy new, state-of-the-art equipment every 3 years.
And on the other side of the wall, you have corporate labs and independent research institutes. They possess the absolute cutting-edge, state-of-the-art equipment.
The really good stuff.
But they operate in total isolation. They are locked tight behind closed doors, accessible only to a very small handful of verified employees.
That's such a waste.
The author points out that on a macro-national level, this results in massive societal waste and fragmentation. You have redundant equipment being built while thousands of capable students never get to touch the tools that define their future industries.
So the solution proposed in Pillar 4 is the shared education infrastructure. This isn't just a university initiative, it is a national level strategy.
It has to be.
It proposes building a physical pillar based on the absolute principle of shared use among universities, enterprises, and research institutes. Rather than everyone buying their own slightly inferior equipment and hiding it away, they pool their physical resources.
And the university acts as the central coordinator and manager for these spaces.
The text explores a few proposed forms for this infrastructure. You have joint labs, where a university and a specific company might co-fund and co-manage a dedicated space for a specific technology.
Makes sense.
You have open labs that function almost like high-end co-working spaces for hardware, which can be booked by various institutions or startups.
Like a gym membership for tech.
Yeah. And you have innovation centers designed explicitly for the cross-pollination of ideas between different disciplines, and practice workshops designed for pure, repetitive, hands-on skill building.
Now, I understand the theory of maximizing the utilization rate of expensive physical assets.
But let's dig into the friction here again. Why would a highly competitive tech company agree to this? We talked about NDAs earlier, but sharing a multi-million-dollar lab with a university, and potentially with students who might go work for a rival company, sounds like a logistical nightmare.
It does sound risky on the surface.
Right. Who pays the insurance? How does a 20-year-old student get credentialed to touch a $1 million electron microscope?
If we connect this to the bigger picture, it requires a completely new framework of governance. But the mechanics detailed in the text make this a highly rational, calculated business decision for the corporations involved. It is not corporate philanthropy, it is strategic self-interest.
Break down the incentives for the corporation then. What's in it for them?
First, there is the raw sharing of costs. The overhead for maintaining and upgrading cutting-edge labs is astronomical, even for massive companies. By partnering with the university, a corporation can subsidize the maintenance, the energy costs, and the upgrade cycles of their equipment.
Okay, that makes financial sense.
Second, the governance relies on strict digital management systems. The students aren't wandering around unescorted. Access is highly controlled, digitally monitored, and tied directly to their AI-assessed competency levels.
So they have to prove they are ready.
You don't get into the lab until the AI verifies you know exactly how to operate the machinery safely.
So the physical risk and the financial burden are mitigated, but what is the active competitive benefit for the company?
It drastically accelerates technology transfer and innovation because you have fresh eyes looking at established problems. But more importantly, it acts as the ultimate extended job interview.
Oh, recruiting.
The company gets a first look at the absolute top talent actually working on their specific equipment, solving their specific problems. They don't have to guess if a graduate can use their proprietary machinery based on a generic resume.
They've seen them do it.
Exactly. They have literally watched that student operate it, troubleshoot it, and improve upon it for the last 6 months. It reduces the immense cost of hiring risk to near zero.
That makes profound sense. The company is basically building a bespoke talent pipeline directly into their own facilities.
Yeah.
And the university benefits because they can offer their students access to world-class, constantly updated facilities without having to bankrupt their endowment to build them from scratch.
Precisely. It aligns the physical reality of education with the demands of the modern economy.
We have essentially laid out all the blueprints now. We have constructed the 4 pillars: the Architect University, the AI Foundation, the Expert Human Network, and the shared physical infrastructure.
The whole system.
Now we need to look at the engine in motion. How does this entire massive machine actually operate collectively? And perhaps most importantly for the author, how does a society actually measure if this incredibly complex system is working?
The operational flow operates sequentially, but also simultaneously. First, the AI handles the heavy lifting of information transfer. It teaches the basic foundational knowledge, adapting to the speed and style of the individual learner.
Then, the university steps in to lead the critical thinking and contextualization. They ensure the student isn't just parroting facts, but synthesizing them into a coherent understanding of the field.
From there, enterprises and the tech experts step in to provide the practical, hands-on, deeply relevant training. They teach the student how to apply that critical thinking to today's actual messy market problems.
And finally, the shared infrastructure provides the physical sandbox to actually build and test those solutions. It is a seamless, continuous loop of theory, context, application, and physical execution.
It's a beautiful design.
But to prove it works, the author insists we have to completely change how we measure success. We have to establish new national KPIs, or key performance indicators.
This is a vital point that often gets overlooked in educational reform. If you implement this revolutionary new system, but you still judge it by the old metrics, it will look like a failure or just a chaotic mess.
We have to move far away from traditional vanity metrics like graduation rates or average GPA.
Because a 4.0 GPA from a system that teaches outdated, irrelevant material is worse than useless. It's actively misleading to both the student and the employer.
Exactly. The source lists entirely new metrics that reflect the reality of this ecosystem. For example, they propose measuring the right major employment rate.
Contrast that with the current system for a second. Under current metrics, if a student graduates with a degree in advanced aerospace engineering and ends up working as a barista because they lack practical skills, the university still counts them in their overall employment rate.
It looks like a success on paper.
But under the new metric, it exposes that failure. The question isn't just, did they get a job, but did they get a job in the specialized field we spent years and immense resources training them for?
That is a much tougher standard.
Another crucial metric is enterprise satisfaction. This means actively surveying the companies that hire these graduates and asking, are they ready? Did they require 6 months of basic retraining, or did they add value in week 1?
Did we do our job as an ecosystem? The framework also measures the health of the network itself, which I find really fascinating. They track the number of participating experts.
That acts as a pulse check. If that number is dropping, it means the university is losing its connection to the real world, and the curriculum is in danger of becoming theoretical again.
And they measure the time spent studying physically at enterprises. If a student's transcript says they spent 400 hours inside a specific corporate lab working alongside active engineers, that tells a future employer so much more than a letter grade in a theoretical seminar ever could.
It proves they can do the work.
Finally, they track the level of AI usage and infrastructure utilization efficiency, meaning, are the students actually leveraging the technology, and are we actually using these expensive shared labs, or are they just gathering dust?
When you align the KPIs with the actual tangible goals of society, the strategic impact is profound. The ultimate outcomes of this engine running smoothly are transformative for everyone involved.
Universities don't disappear.
No, they retain their central, vital importance as the trusted hub and architect of